Hi guys! Today we are looking at section 12.3 on domains of functions. So again, I like this lesson. They've made it simple for you to look at something and figure out the domains. So first, what is a domain? Okay, so a domain is the set of all allowable inputs. So any allowable input in a function is part of the domain. And for some functions, that's any x value. Okay, for some of them, there's limitations because we can't have a negative number in the radicand. And for some, it's that we can't have 0 in the denominator. And those are the things that exclude values from working, from being part of, being part of the domain of a function. So, so if we go back to my candy machine thing, that has a limited domain because there are only so many letter number combos in the machine. It's not unlimited. And so that is a limited function in that I can't pick any, there isn't anything possible. I'm limited to what's in the machine that I can push. Okay, so first off, we'll start with the easy one. So if it's a polynomial function like this, okay? Remember polynomials where you have terms with your variables and they might be squared or whatever, okay? So the value of the exponents doesn't matter very much as long as it's f of x equals and then something like this, then all real numbers. Any real number becomes a domain of that function. And that's the nice thing. So polynomials, all real numbers are part of the domain of a polynomial. And real numbers are the only numbers that you know right now. You're not worrying about imaginary numbers. But that is kind of what comes up here. Because we're only looking at real numbers for our domain and our range. The range is what you get for your y values, your output. And so we can't have imaginary numbers, which means that you can't have no negative radicand. Okay, so that means that x minus 5 has to be greater than or equal to 0. That's my limitation. X minus 5 has to be greater than or equal to 0 because when I put in a number for x, I can't get a negative number in here. If I have a negative number in here, then I have an imaginary number or a complex number, and we're not doing imaginary numbers because we're only doing real numbers. Okay, so I don't want any imaginary numbers. I can't have a negative in the radicand. So this is what you do. You take what's in the radicand and you say that that thing has to be greater than or equal to 0, and then you just solve that. So I add 5 to both sides, and so I get that x is greater than or equal to 5. Okay, so that's my domain. As long as x is greater than or equal to 5, that is my answer for this thing. So you take what's in the radicand, you take this, make it greater than or equal to 0, solve for x, and that's your answer for your domain. Okay, in a rational, your domain, we cannot have 0 in the denominator. Okay, I'm sorry for my handwriting. Like I said before, I do not like these. But I didn't want to go out to my classroom because the internet is not great out there. So this is what I have. I'm going to stop whining about it now. Maybe. Okay, I'm going to stop now. All right, so here's my function. H of x equals x plus 3 over x squared plus 2x minus 8. So I cannot have a 0 in the denominator. So when I am doing my domain, I need to say x squared plus 2x minus 8 cannot equal 0. So I need to solve and figure out what values x cannot be equal to. So let's look at this one. Hopefully we can factor this one. So what do I multiply to get 8? 8 and 1 and 4 and 2. But I need a difference of 2. So I'm going to use 4 and 2. And the 2 is positive, but the 8 is negative. So that means that the 4 is positive and this 2 is negative. Because then I get 4x plus negative 2x, which is positive 2x. And 4 times negative 2, which is negative 8. Those should be quick and easy now. Okay, we talked about that. If it's not, you need practice. Okay, and I can give you stuff to practice with to make that easy, but that's really important. That will help you because you won't use it as much in geometry, but you'll need it when you get to Algebra 2. And so you're going to have a gap in between those two classes, and you'll want it to come back to you quickly. Okay, so that means that if I look at x plus 4 cannot be equal to 0. And x minus 2 cannot be equal to 0. Because if this is 0, then that's going to make the whole thing 0, and I'll have a 0 in the denominator. Okay, we just spent a whole chapter working on stuff like this. Okay, so that means if I, let's do the right thing here, add 2. So over here I have x equals, or x is not equal to negative 4, and here I have x is not equal to 2. So these are my values. So my domain for this one is going to look a little bit different. I'm going to erase this here. So my domain is all reals except for x equal negative 4 and x equal 2. So all the reals will work except for those 2 values. Okay. The last example I'm not going to go through just to save time for me and for you, but it's a combination problem. So where you have the radical on top and you have a possibility for a 0 in the denominator. Okay. So for this one, you have to do both things. So you need to make sure that this x minus 3 is greater than or equal to 0. So that will be part of it. And you'll need to make sure that x minus 5 doesn't equal 0. That's the other part. So this example is in your book, so you can look there and see what that looks like, and that should help you. Okay? So I'm going to be done for now. We're going to do the blues for this. I think this week, from my perspective, but I'm wrong sometimes. It seems like it's going to be a pretty straightforward week. This is your last assignment for the week. You only had 3, and we're still on track to get finished with everything I wanted to. We just are missing chapter 10, which is okay. So, yeah, I'm kind of rambling now. It's weird doing videos. I just want to be with you guys. So anyway, I love you and I miss you, and I hope someday we get to do math together in person again. Except for Gavin. I get to do math with Gavin all the time. Like forever. So, but everybody else, I miss doing math with you. Bye.